What if a variance of 1% that you weren't even aware of, was costing your company, you are a stakeholder, around $60,000 per month? And what if you had the ability to find that 1%? Would you jump at that opportunity? Good morning and welcome to today's live webinar, Balancing the Value of Data. Today is session 3 of the series, Business Transformation through Digitalization. This term will be explained to you shortly, but before we begin, I would like to thank the Southern African Institute of Mining and Metallurgy for agreeing to host this session for your benefit. Given your expertise and experience, we would really welcome your participation and encourage you to make comments and ask questions, and we will address those at the end of the session, time allowing. Otherwise, we will answer those questions individually in emails after the webinar. For a better viewing experience, please click the view button at the top of your screen and then focus on content. I'd like to introduce Dilly Naidu, Director of Rifle Shots Performance Holdings. We're celebrating our 22nd year of service to the mining industry this year. Dilly is an internationally experienced business leader with 35 years of industrial experience. He's been a dedicated martial artist and marathon runner for the past 57 years. And Dilly's really passionate about exploring ancient cultures and cultivating new ideas. Dilly, over to you.
Thank you, Caroline, and greetings to all. To my colleagues in Milano, in Italy, buongiorno. What I wanted to do this morning is, before we hand over to our doctor professor on the main subject today, post-COVID, there's been a frenzy for what is commonly known as digital transformation. And based on this research that has been conducted globally, in excess of 70% of digital transformation have failed to date. And there are a number of reasons of why they have failed. So what I want to touch on today and use the analogy of the picture of the bridge that you see. And as a child, I've been fascinated by bridges. And what is the purpose of the bridge? It's to connect from point A to B and allow you to go smoothly across. So even as a child, growing up in a rural area, we used crude poles that we walked across to get across the bridge. And that was quite exciting that we could go across this bridge safely. For those of you who've traveled to parts like outside Louisiana, in the state of Louisiana, you'll find there is huge bridges that are running as far as your eyes can see. And it's fascinating that you understand how this has been put together. More popular ones in San Francisco, the Golden Gate Bridge. I've been in bridges in Hong Kong that are underwater. Just fascinating. I've been to crude bridges in South America built of reed that you walk across. And now, especially in China and in India, there's unbelievable construction of bridges. So this is building a solid foundation. So why don't we adapt the same kind of philosophy where we have an architect, where we build a solid foundation before we embark on technology? So one of the main reasons that this has failed as far as digital transformation is people have been leading with technology. You also have a number of legacy systems that you've already invested in. So how do you build this bridge where you preserve the investments that you've already made while you're taking advantage of the new digital technology? So you need to build a solid digital transformation journey roadmap, because this is not an event, it's a journey spanning a number of years. In our experience with our clients, we would suggest that you begin the journey with an initial prioritized proof of value, where you can demonstrate proof of business value, and then you replicate this across the organization. One of the key issues that we find in organizations, as they get bigger, the silos and divisions in the organizations become deeper. So we've created a formula for organization integration, which is called IQ multiplied by EQ multiplied by SQ, DQ, AQ, which gives you OI. So IQ, we're all aware of, our intellectual quotient. Emotional quotient is very, very important today. in terms of understanding how people feel and being part of belonging to the team and the organization. SQ is very important today, largely around the automation that's taking place, the business process automation, and DQ having a digital first quotient, and AQ where the organization is evolving and changing based on a number of outside influences. So you have to be agile. And if you do that, your organization will be better integrated. I just wanted to touch, while we're on business transformation, in the last year or so, there's been a lot of focus on so-called AI, artificial or augmented intelligence. So the question is it artificial or real? And my wife and I have been observing so-called artificial plants and flowers. And over the years, it's unbelievable. You could hardly tell the difference between an artificial plant or flower and a real flower, so much so that we go to touch it, and even when we touch it, it feels real. Now, although AI started accelerating in recent years, it's been around for almost 7 decades when the term was first coined. In the 90s, we've had machine learning, and you'll find this word algorithm consistently across the whole area of artificial intelligence. So we had these algorithmic models which are trained to work with existing data and help us make decisions and predict stuff. And then in the 20s, with neural networks, we had deep learning, where through these neural networks, we could expedite and make faster decisions. What was a game changer was last year when ChatGPT was introduced, and where we now have generative AI. And this is available to almost all and sundry. So you're able to use technologies like ChatGPT and other technologies that are evolving, which was the preserve of very specialist computer scientists previously. I just heard a lady apologizing for a novel that she just recently published to say, I'm sorry, this is not my authentic publication. I used AI with ChatGPT and using the generative AI technology. So this novel was developed through this artificial intelligence. Now, similar to the previous slides that you've seen around digitalization, with AI, what we found is people are buying a technology. Now, this is very important because it's part of your business growth and development. So you need to develop a business strategy and how you include AI as part of the overall strategy. And of course, you need technology. So you need to have a technology roadmap and strategy. And you should start by looking at an AI strategy and exploring and experience the capabilities, similar in what we talked about in the previous digitalization slide, where you start experiencing and gaining some proof of value. We touched on organization and integration. This is exactly the same, because it's a game changer when you're starting to use AI. And of course, change management. Last but not least, one of the biggest issues right now is around governance and regulatory compliance. In Europe right now, they are working on regulations. For those of you who follow American football, just recently, there was Taylor Swift, who was the guest appearance at halftime. And already through AI, you've had clones of Taylor Swift in pornography. And this could be very damaging. So AI could be very, very positively used or negatively. It's similar to a knife. You know, in my household, and I'm sure in all your households, in your kitchens, you have knives. I have various flavors of knives for different functions. And that's a very good positive thing, that I'm able to do things with that knife. But the same knife can be used for cutting and bleeding and stabbing in self-defense. So with AI, you have to be very, very careful in terms of the positive benefits, but also the negative use and implications of use of AI. You know, in a short presentation like this, we would not be able to do the full justice of what AI or augmented intelligence can provide to you. But some of the areas for this audience, based on our experience as an organization, we look at AI in mining, oil, gas, exploration. For many years, I visited the annual conference with the oil petrochemical industry in Dallas Conference Center. And you'll see they have a formula of what they talk about, 1 in 5. So the idea was 1 in 5 holes, they will go and gear up and spend a lot of money digging 5, what they call dry holes. And if they're lucky, they'll have 1 hit. Now, why don't we use AI, connect all the geological information, where we get to a stage where we have one intuits. Rather than digging 5 holes, we dig 2 holes based on AI predefined analysis, with tremendous savings in an environment like that in the mining and the oil and gas business. In the underground seismic movement monitoring environment, I was personally involved previously where we used physical sensors to do 7 by 24, 365 days a year monitoring. But now with AI, we could do the same thing. We could do 3D seismic monitoring and proactively look at the seismic movements and remove people from undergrounds. And this could be a tremendous benefit in helping save people's lives. Of course, some of the more common areas are the whole area of self-service. So we can move from self-service to proactive decision-making. So I'm sure a number of you use Netflix and Face and YouTube, etc. You'll notice it picks up a profile of you and starts bringing the kind of things. So it's proactively doing things. And this can be applied in a number of environments, from retail to telecoms to banking, financial service, etc. The whole area of customer engagements. So, this whole area of chatbots. I've been involved in speech to text for many, many years. And most recently, I've seen the launch of the Samsung S24 Ultra. And I was just blown and amazed that it's taken almost 40 years to get to where you could do almost real-time translation from English to Spanish or any other language. So you'll find a lot of the chatbots that I've been exposed to have been a nuisance. It's been more of a nuisance than actually allowing me to benefit and experience the benefit of having a chatbot. If you look at legacy technology, there are still a number of mainframes with a lot of data. The financial services sector is one example. Over 70% of the data is still on COBOL. I was brought up in COBOL. The Generation C today do not understand what COBOL. They're more accustomed to technologies like Python, etc. So through AI, through the PDFs, you'll be able to do this and minimize the amount of time on these kind of, in the areas of automotive inventory management, and supplementing the actual physical robots that you see with cobots, where you have humans with augmented reality. So these are some of the examples that I wanted to share with you. So with that, I'm going to hand over to Caroline.
Thank you, Dilleen. Next, I would like to introduce Dr. Felicia Moody. Felicia holds a PhD in chemical engineering from Loughborough University in the UK. She has extensive experience in steady process, mass and energy balance simulation, steady state, mass and energy balance, and over 10 years of process engineering experience. Felicia is a global citizen, having lived and worked in 3 continents. She is an enthusiastic traveler who revels in the beauty and diversity of this miracle we call Earth. Felicia, over to you.
Thank you. So let me request control. Okay, I'm requesting control. Do I have control? Yes.
You have control.
Okay, thanks everyone. It's really a pleasure to have this opportunity to speak to everyone. Dilly did a great introduction of, how we can augment data to add value. There are many tools, many vendors, many service organizations that can, let's say, construct this bridge, moving you from where you are to where you'd like to go. It's my pleasure to introduce our company, PIMSoft, and our software, and more importantly, which values we can bring to the table in your digitalization journey. Caroline, it doesn't go down. Okay, so it does. So Sigma Fine has been around a while. The product has been around since 1993. It was acquired by Soft in 1999. In 2010, it was acquired by PIMSoft, which is still the current owner of this company, of this software. Through this journey, we moved from AF technology, OSI, it's now Aviva, asset framework technology. It stayed in that technology, exclusively until 2020, when the technology now exists in the Aviva AF technology. But now we are moving to have a parallel experience, which is web-based. So we are also moving to let's say thin environment, which is far more cost effective and efficient for your organization. In 2022, we were bought by Valsoft. we were acquired by Valsoft to further develop the product. We are still, PIMSoft remains an entity fully owned by the Valsoft Corporation. So before Valsoft, we were up to 75 persons, let's say, in our peak. And it's been a game changer. Now we are part of an organization that has over 30,000 customers. And we are almost 3,000 employees. So it has really changed the way we work for the better, let's say, and for the benefit of our customers. We are not the only technology that Valsoft has acquired. There is a health and safety group within operations technology. There's an industry ERP division with a product below. And we are in process and manufacturing, which is PIMSoft and Fusion. Fusion is completely web-based. So Valsoft is growing this operational technology group, of which PIMSoft was the first of the process and manufacturing, which took place basically 1st of 2023. So within 1 year, we have a sister company, Fusion, and we keep growing. But what is Signify? So we've been around, as I told you, since 1993, and our job is to turn your measured data into value. Okay, we can connect to, let's say, everything goes to your historian. We can connect to your historian. If you have a movement system, we can go through your movement system. We have an integration layer that allows us to connect to your process data and your business data centralized. Signify is an infrastructure where we validate data, we can reconcile, and we can condition the data to meet a business value. Primarily, it's production accounting. We also have material tracking, energy balance on your utility side. But in all, the commonality in all of this is minimize uncertainty and improving the value of your data. So it is consumable, trustable, and transformed to make a business decision. So we're moving from time series data into a loss asset utilization, or your production report, or your yields accounting, or data to feed your planning and scheduling system so that you can make better orders for tomorrow because you're using a data which is free from error. Fine, I'm not able to go to the next slide. Okay. Okay, so the next slide is just, my presentation behaves a little bit different in this environment. So what we start with your confidence in your data. So it's your measurements and your confidence. Signify, it's an open environment. We can do daily balance, period, let's say. We can go near real time down to 15 minutes. We can do a batch if you have a batch of 27 days, or by event or monthly. So it's open. What's inside our server is a balancing algorithm. This balance can be mass, volume, energy, component, or a combination of the two. For example, mass and energy, or mass and component, let's say, that is typically used for the metals and mining world. We do have a tracking layer, which is often used to track business properties like ownership, or even your financial architecture. So you are 50% owned by one entity and 35% by the other, and you want to distribute your materials according to your ownership or the source, which mine delivered the materials. In the end, behind Signify, all of this goes into a model and into a centralized database. And this is our database is AF and SQL. And this is where you can really share your data with your AI tools. So you can push data back to your planning and scheduling. You can push data back to a performance optimization tool. And so this data that we send back is free of the typical errors that occurs if you try to do a mass or an energy or mass and component balance on your raw data. So let's take, what is the starting point? Okay, we are on the left-hand side of the bridge and we're trying to get to the right-hand side of the bridge. So on the right-hand side, we're trying to do some performance optimization. On the left-hand side, we have these kinds of problems: missing data, poor design, a defective sensor, and sensor failed, lots of things. This can happen either on the instrument itself or in the collection of the data, of the streaming data. Yet we still want to give good data to our scheduling and planning system to tell us what we should be ordering for the next month, let's say. In metals and mining world, we are halfway through. Just to recap, some numbers that we know where we're starting. So Bulk density, we know that this has a high variability. Inventory, very difficult to do, quite expensive. Variability of typical 5%. On concentrates, when we go down here, it's better. We're down to the 1-2%. We know that online analyzers today, they're good. Data tomorrow, depending on what happened in the last 24 hours, can change stuff. Moisture content, concentrates when you are selling intermediates, they change. Moisture can really affect the declared value of your concentrate from the point of measurement when you send it to the receiver. Yet at the same time, this is on your instrumentation. This is the meat of the matter in the metals and mining world. When we get this data into our data lake, we know on the left hand side we have different sources. We have, as I mentioned, you have inventories, which can be a dip, it can be radar, and each type of measurement has its own limitations and vulnerabilities, let's say. And of course, it's a big part. You always start on your left. The first thing is to have measurements. Without measurements, you don't know. Collecting it is very good. Okay, so we have the history, and we're saying today, let's condition this data so that it is in a form that you can utilize to make business decisions. So that's where SigmaFine come in. We are a part of the picture. We are not everything. On the orange, you need your instruments, as bad as they are, as unreliable as they are. But this is the source. You need to capture this data. We need a history, and we're saying don't forget cleaning up this data, transforming this data so that it become accurate and reliable. That's where we come in. Rarely, we are never called to do a mass balance or a component balance. We are called when our customers need this kind of things, okay? Corporate governance. You have a rule that tells you your financial record must be based on data which has a certain uncertainty, and to meet this requirement, you're forced to do a solution would be mass and component balance. Toll contracts. I'm sending you a concentrate. You are buying it. We need to monetize this material. It's in a tank. How do we monetize this in a fair way? Again, okay, a compromise is let's do a mass and component balance on my side, on your side, and we have a value which is the minimum error of this, not just the absolute measurement, but one that is coherent with all my other measurements. A new one, which is, it's not new, but let's say it's becoming a top priority for organizations even before a requirement of the state, where if you go to, let's say, a financial report, you will see that not only do they report their production, but they will report their emissions, their greenhouse gas, GHG reporting. If you try to do your GHG reporting using your measured data, we know we're going back to the area of 5% uncertainty, 8%, 20%. It's not good when you're reporting that high level of uncertainty to the state and to your stakeholders. Another part is also on your utilities. It can be energy or water. These are good KPIs to bring your costs down, but also as a corporate citizen. Again, it's a server. We do energy balance, volume balance. It's the same server. There is no duplication of let's say, IT infrastructure. It's all there. And again, to do a good reporting on your water consumption or electricity, or customers which have been using SigmaFine on the production side is now using SigmaFine on their utilities to correct monetization and declaration of their consumptions to their trading partners as well as to the state. These are just some examples, this is B2 Gold, where we see that their production statement does have the final mass. It's not just in money. And here we're absolute. We're moving with all the uncertainty. We need to get to a final figure that we declare to our owners. This is at the end of the day. Let's say at the beginning of the year, we also have to put some guidance on our production or operating cost, okay, and what we expect to sell it for. And here we see our variability of 8%, and it's correct. As we discussed before, we know our starting situation that we have a lot of variability, and when we're setting our targets, we give ourselves some space. Should it be 8%? Can we get it down to 2%? It's up for discussion. But let's say this is where we are today as an industry. This is just an example when you're selling let's say intermediate products. Again, just to get money, your composition is a price. Your uncertainty is a price. So they're saying that this is 97.5% of what is measured it will be paid for. It's up for discussion. Should this be 97? Could this be 98? Okay, could we get 98% of our measured value? In gold, it's even worse. They're paying you 92% of your measured value. Can we improve our data quality so that we can get to 95% of what we measure and so forth? This is on your positive side. On the negative side, on deductions, again, they measure your impurities, and we have some reductions. And here again, this is all debatable, and they said these are parameters which are historical based on our history of the goodness of our data. So as we improve the quality of our data, we can see that we have a potential to improve our financial. This is from Anglo American. You can see beyond their production reporting and their financials, we see that their energy consumption is being reported, and their equivalent greenhouse gas emission is being reported. We've done GHG calculations for our customers, and we do the mass balance, and we do it, let's say, equivalent CO2. So we know that behind this value, it is a mass balance. Behind here, we have an energy balance to give the good data that you can put a bar without putting a big error of 20% on these consumptions. So the message here is we are here. This is where we want to get. This is more like on the other side of the bridge. On the left, we saw all the problems. So how do we transform ourselves from problems in our process data to GHG to energy balance to good financial data? SigmaFine is very simple. I like this slide, and I talk to everybody. This is what we do. If you look here, this is 11 assets for us. It's a balance point, 5 flows, and 5 measurements. To give an idea, our customers, we have them from 250 elements up to 20,000 elements. And we are solving this in less than a minute, a couple seconds. So SigmaFine's job is to reduce, if not eliminate, your measured imbalance, and also to improve the uncertainty in this new data set that is created. This new data set does not override your measured data. Your measured data is maintained and preserved, and the reconciled data is a new data set, okay, which has been transformed, where the errors have been minimized, as well as the uncertainty of this data set. So this is, in a nutshell, what we do. We do it on energy, we do it on mass, we do it on mass and component, and this is just to show you that for every schema, where you see a balance point, this is the equation that is being run in the background. You're just dragging and dropping, but there is a math behind it that is minimizing the errors. It's taking all of your mass, its composition, it's measured inventory on the named composition, and its job is to minimize, if not make zero, the imbalance that is measured, that is present in your measured data. This is just to give an idea of what a SigmaFine model could look like. Our assets are always the same. We have some meters, we have some analyzers, we have flows. It can be measured or unmeasured. We have a balance point, the nodes. We have process units, a grinder or something like that, electrowinning cell or a leach cell. We have boundaries, inputs and out. And component balance is a nice thing for SigmaFine, where we activate it where you have compositions. So here we have compositions. Here we would activate mass and component balance. Here we have only mass. Here we would activate only the mass. The mass and component balance would not be activated because we don't have analyzers. And here again, we would activate it. So SigmaFine mass and component balance, which is, let's say, the foundation of metallurgical accounting, is activated where you have the appropriate measurements. As you add instruments, let's say in the future on the leaching area, you add analyzers. We turn on the flag, and we can also do the composition balance there as well, the component balance. So in the previous slide, it was, process unit, it's grinding, it's a beneficiation 1 block, leach 1 block, and so forth, okay? We can also go to, this is like following a business chain from cradle to grave. We can also open the box, so this is like a beneficiation plant, where we show each process unit, each input, this is in one process area. So it's exhaustive, but in the sense, it's the number of elements, the type of elements is still the same. The number of elements, of course, expands. So this would be like 250 just for one area, while in the previous model, we were at 300 elements for the entire flow from the mines to the finished product. So the granularity is open, and it's the customer that decides the granularity of the model. So if we look at the flash float concentrator, we can just to give you a quick idea, we do the mass and component balance. We have an imbalance, not a big one on the total mass. However, it's quite significant on the copper. We run a mass and component balance, and the imbalance is eliminated on this flash float cleaner. So that's what SigmaFine is doing. Just to, let's say we finished the theory, and let's see what organizations have been doing with mass and energy balance. This is a nice example, okay? It's rutile production. It's highly energy intensive. And we find, I like this one because it is a mixture of data and operation. So it's not just doing your energy balance to report less energy consumption as the years goes by, but it's also to support operation projects. You know, we have a big energy consumption on this rutile kiln, and so we do good projects, okay, and we have a good mass and energy balance to estimate the improvement of the investment. So here they did physical projects, but data driven. So this asset was selected because it is a high energy consumption. Mass and energy balance is implemented before and after, so they can do the delta and relate it to the investment that took place to improve the performance of this furnace. So I would recommend anybody who is using SigmaFine or is improving their data for operations that it's not just to clean up the data to reduce uncertainty, but it's also to assess, to drive, let's say, operations project to improve your overall performance. So a 10%, 9% reduction, 5% reduction in energy for any size of organization, it's a big saving. So you can take these percentages and think about your consumption, and if you should use a data reconciliation tool and use it to drive your decision, one of your parameters to invest. This is what is achievable. Okay, it's not a pie in the sky. These are real numbers. If we just look at a case where it's only data reconciliation, so it's a simple plant. It's in Brazil, bauxite. It's very simple. They bring the mine, crush, okay, clean it up, and they send it through a pipeline, okay, and it is received. The water is removed, and it goes to the refinery, the bauxite refinery. Everything looks really fine, okay. This was in 2007. So just to give you, this is the uncertainty that happened, okay. So the plant was designed to operate with, they thought they were having 65% recovery, okay, of the bauxite that they mined, if they use their measured data. Instead, it was 60%. So they were rejecting 30% of the mined material as waste. So this is a 10% reduction, okay? And what does that translate to in 2007? So bauxite value is a little bit more than this today, but even with these historical prices, they were losing 30 million of revenue because they were throwing away 30% of this material as waste instead of 25. So, and this is just mass balance, okay? So even before you start to do project improvements, just having the knowledge, because this is just knowledge, that your beneficiation plant is not performing. It is wasting, it is sending 10% more to waste. So you need to reconfigure your cyclones, you need to probably clean some of your solid liquid separation and so forth. But the plant was designed for producing 65%, not 60. If you use your measured value, you would be off by 28 million per year. So our customers, we have metals and mining customers. I do this very quickly because the full presentation is on our website. You just go there, you can download. Codelco, it's nice. They're using SigmaFine from cradle to grave, okay, from the mines to the gold, the molybdenum or the gold bars that they sell. But they have 7 mines, 2 refineries, and 1 finished product. So the way to minimize losses, their vision was to have a good integrated, standardized metallurgical balance. It's not just to have the balance but the objective is to take control of their losses. So what we mine, we should know what we mine. We should know what goes to the beneficiation. We should know what goes to the refinery and to the finished product. And the way to do that is to have, their vision was to have a metallurgical balance that is integrated to the financial data. both on the input side, you can see on the sales, and also on their products. So SigmaFine is a part of their metallurgical balance, but it is also integrated into their financial records. This is a vision of a company, okay, that has been implemented. This is a completed project, and this is in place. They have but what do they find? This is just this was their vision. This is a table with flow meters, analyzers. You see concentrate. You see percentages. So these are analyzers. And if you do some ratios, you'd see that this is about 5% out. Okay, so this 5%, 8% uncertainty, it's there natively in our data set because of the nature of metals and mining. But SigmaFine is able to minimize, if not eliminate, this imbalance, okay? And at the same time, tell you that you have a problem on this measurement. Codelco, they moved from everybody doing their own method of production accounting and to an integrated approach, standardized, so they have full control of how their measured data is transformed to their financial data. This was their objective, and they have achieved. We have another use case, which is let's say less authoritarian. Okay, this is ArcelorMittal in Canada. I worked with Emile. She's a very nice lady. And this is ArcelorMittal in Canada. So they have the iron ore mine, they have the beneficiation plant, they have the pelletizing plant, they have the trains, and they have the ship. Okay, this is their chain. SigmaFine is not here in the beneficiation plant as our demo. We are here in their pelletizing plant. Before SigmaFine, there's always a before SigmaFine. Okay, we all do production accounting. We're all called to report. If we don't have an infrastructure, we do it in Excel. We do macros, and that's what she was doing. Emily was doing. It took a week, so they were at weekly balance aggregated to monthly. So imagine running your plant knowing you have a problem 1 week later. What is the cost of data that arrives to you a week late? It's very expensive data. Okay, so she pushed for a better system. She had some other problems. It's bulk, and we know the nature of measuring bulk material is difficult. The inventory is only measured twice a year. Okay, we're trying to move to daily balance. The product is not weighed. So we only have the mass on the input to this pelletizing plant. We have the inventory twice a year, and we're trying to do a balance. This forced them to do mass and component because we have two data sets. So not just the mass, but the component, and becomes solvable. ArcelorMittal used a SigmaFine in conjunction with other products. We see Excel, we see Pi, we see Microsoft. Okay, so their job, they moved the production data onto really, this is a bridge. So we're moving from time series data from Excel, typical engineering data, to Power BI, where Pi Vision, where asset utilization and production linked to the asset utilization is consumable by the decision makers immediately, let's say. The model of a SigmaFine is the same, as we mentioned before: analyzers, flows, process units, inventory points, inputs and outputs. Just to give you a snippet that we are really connecting the assets. So this is a measurement, this is a silo, a point of inventory. We have an input, we have an output, we have analyzer, and there's also a meter on this. We are AF based, so you can view the entire SigmaFine model in the asset framework. You can also view it in our SigmaFine hub. You can view it in Excel. You can even view it in the old process book if you still have one. You can also view it in Pi Vision as ArcelorMittal did. So they drew a flow sheet. We build a model in AF. They build a model in AF with our help. And they view the data in Pi Vision, where green, the data is good, red, the data is not acceptable. So here they have measured data as well as reconciled data. If you go down here, there's reconciliate, which is the reconciled data. Beyond that, they push the data to Power BI, okay? So the data is consumed. We looked before that we saw flow sheet, temperatures, flow, analyzers. Here we are seeing productivity of the plant, of each furnace, the feed to each furnace, and which asset is not performing. What is causing us to produce 5%, beyond 5% of our target? And immediately the bottleneck are this feed to the furnace. So they know which asset is causing the deviation from their target production. They can also data mine and see the history, okay, of an asset. to see, is it just today or has it really been underperforming for a while? So ArcelorMittal moved, okay, by themselves almost, from weekly mass and component balance in Excel, okay, to this, where they grouped mass and component balance with operation asset utilization. So, and this is shared with an hyperlink. So I would say this is a really good example of a bridge, okay, where we're moving from the impossible, okay, not knowing, having your inventory twice a month, twice a year. So it's capable. We have a good team between PIMSoft and RifleShot, and our job is to bring these assets to you, and when you are ready, to help you consume it in a very efficient way. Just to let you know, we are not only on the production side, we are also on the utilities. So we normally enter our customers' environment via, we need to have good production accounting data, or we need to have good performance monitoring data, so we know which asset is underperforming, because we have this high variability in our measurements of up to 20%. But we're also called to then to use the same software, the same infrastructure, to look at water balance. Water balance is a little bit different from the other models that you saw. It's mainly just receipts and shipments. There tend to be lots of manifold, and we have some inventory points, and we have inputs and outputs. So when we go to utilities, the icons become more homogenized, because it's the same utility, and it's either a manifold or an inventory point. So bear in mind that SigmaFine can also be utilized quite effectively on your utilities measurement as well. I hand over to Martin. I remain available to answer any questions, but perhaps it's good if we could just listen to how PIMSoft and RifleShot works together. I hand over to Martin. Thank you.
Thank you, Felicia. I just want to quickly introduce Martin Marion, who used to be an avid golfer, but his children had other plans for him. Martin, true story. Martin holds a bachelor's degree in industrial engineering from the University of Pretoria and an MBA from Henley Business School, with a focus on advanced planning and scheduling systems and their implementation, which he's been specializing in at RifleShot for the past 19 years. And Martin is really happiest when he's engaged in engineering products that show tangible results. Seriously, that's how he has fun now.
All right. Thanks, Caroline. Thank you also, Felicia, for that presentation. I think a lot of stuff to take in. And just to sort of tie it all together, what I'd like to share is, Dilly talked about digitalization and how you get from one point to the next, and Felicia took us through some details on a specific part of your value chain and where we can add value. Well, like she said, just by looking at the data, not even doing anything, just making sure it's more accurate, but also how that accurate data can later on, support operations, etc. But taking a step back more from the RifleShot, and often from a RifleShot point of view, and often when you hear about digitalization, and all these terms, or the digital transformation journey, etc., I think it can be a bit overwhelming, because you have to go out and do it. Everybody talks about these fancy terms, and even artificial intelligence and machine learning, but what does it mean, and how do you get to use these technologies in your business, and how do you add value? So, from a RifleShot point of view, what we try and do is take a holistic view at your value chain, and the example we have here in the slide is a mining value chain, where we talk about not only pit to port, but pit to profit, because at the end of the day, we obviously need to show value to our shareholders, and make sure that their investment delivers the value that they're looking for. And RifleShot looks at this whole value chain, and we try to look at a product agnostic mining platform. So, we won't necessarily push any technology, but we look at where's the problems, where's the opportunities where we can add value, and do we have a solution that can talk to that opportunity and deliver a result for the customer. So I think it's very important in today's terms that you just don't go out and buy a specific technology, and it all looks great in the presentation, but it might not be the right fit for you. You might not be digitally mature enough, or you might be using one thing to do something that it's not really designed for, and that leads to, like Dilly mentioned, some of the failures that we have with digital transformation, initiatives, etc. Ryan, looks like you stopped sharing. Just share from my side. Sorry about that. Let's do this. Maybe the load shedding started at 11 instead of 10. Lost Caroline. Quick recap of Alicia's stuff. Alrighty, there we go. So looking at the whole value chain and seeing what solutions can deliver immediate value on that digital transformation. And I like to use the word journey, because all of these things, you can't just go out and do all the technology everywhere in your value chain and think that it's going to work. Tilly also mentioned that, and establishing a proof of value where you use one part of the value chain, maybe a specific value stream or even a specific asset, and just start with that and see if what we do adds value, and then we can obviously replicate that through other pieces and maybe look at other solutions. I think it's important to keep that goal in mind, that it's a journey, and you take it step by step, and by obviously a continuous journey, but as you go along, more and more of the value chain becomes digitized. So, in that spirit, what Rifle Shot does is, we're not linked to a specific product. We've got a whole host of partners that we have that's what we think best in class. And these products would either have a specific niche within a specific part of the value chain, or a specific value stream where it's got a definite advantage over its competitors. They might be doing a great job with coal, but they're not as well with some of the precious metals, or whatever the case might be. So from a Rifle Shot point of view, we look at starting off at the mine itself, on the coal face, where we've got some technologies that looks at stockyard management, looking at your stockpiles, quality of stockpiles, etc. Then, as you process and ship the materials, you look at some technologies from Aviva and Ion Training in terms of the managing your production, looking at the planning, making sure that you're making the right product at the right qualities, delivering it on time, making sure that you can deliver to your customer, which then, obviously if you ship out, overseas, we look at products from Clavernous Digital, which helps you manage your shipments, making sure that you're not missing shipments, that you're not, running out of stock at the port, and obviously with all the challenges that we've been experiencing, which I'm sure all of you are aware of, at least giving you the visibility of what might happen and reducing some of those uncertainty. And then if you look at the bottom three products, these are ones that more look at processes within your entire value chain, and obviously the one that we've been looking at today is PIMSoft Sigmafine, and we also have a solution when it comes to electronic permit to work, which we're implementing at some of the big mining houses in South Africa, and lastly, also another one is a Soft Expert with their Soft Expert suite, which is more focused on taking a step back on your ESG and your GRC within the product. So Rifle Shot has these whole bunch of products, and what we like to do is really get involved with the customer and understanding what their specific needs are. Each customer, you might be following the same process, but there's different challenges for everyone out there, and there's also different opportunities where you can get the most value out of the very quickly, the low-hanging fruit, like we always like to talk about. And these are the ones where that's good opportunities to start with the digital journey, so that you can show value in digitization or digitalization, and then roll it out towards other parts of your business and other value streams. We've got like you see Dilly there and everybody, we've got lots of experience, people that's been in the industry for many years. We'd like to not only have that typical consultant relationship, but look at a resultant, and I like the fourth point there, more of a trusted advisor partnership. A lot of our customers we've been dealing with myself for almost now 20 years, and some of the other colleagues of mine for more than 40 years, they've had relationships with these customers, and you build up that relationship and make sure that there's an honesty there that can only come with time and delivering. And when it comes to delivery, obviously, we've got a established program and project office, and after we've implemented the first phase, we go on with ongoing support. I think that's very important, and that's also what Rifle Shot does well is, we've delivered the project. It doesn't help us just leaving there and leaving you to go on your own. Let's keep on supporting that project, and as you get to know the product much better, we can look at how can we use that product or that solution in other areas as well, and that's where the value comes from at the end of the day, because a lot of the times you're only using a small percentage of the capability of that product. So we like to keep that partnership or that relationship going, and making sure that there's always good communications between what you're thinking, what your vision and strategy is, and our Rifle Shot can support that. Let me just check if Caroline is still online.
I'm here.
All right, I can hand back to her. Caroline, I don't know if you want to share, or I can just continue sharing.
This is perfect. Thank you, Martin.
Sure.
And thank you for that presentation as well. Are there any questions from the audience at this time? Okay, I don't see any open ones, but I have a couple of questions. And the first one is for Alicia. What are the prerequisites that would be required before embarking on an implementation journey of SigmaFine in particular? Do you need to have any foundational platforms first?
Okay, well, as I mentioned before, we use a lot the measured data as well as your estimated data. So SigmaFine before instrumentation is not advisable. Okay, so this is the really foundation. We come in. Okay, the assets are built, and we have some level of redundancy. It's not mandatory, as I showed. We had two extreme flow sheets. One where we had meters and analyzers on every process unit. Okay, and I showed another flow sheet which was a pit to port, which had if you were to add it up, was a smaller model than the beneficiation plant. So saying that, when you do a SigmaFine, you always have to think of my objectives that I'm trying to achieve. Okay, am I doing production accounting? Am I doing performance monitoring? What measurements do I have? And in the middle, considering these two, the left and the right, that determines the level of modeling and detail and granularity that can be done. But let's say SigmaFine comes into play when we have measurements. So it's really, really important to have the data, the measured data, as well as the confidence of this data. And from there on, we can start, and we can move from a high-level model, okay, that is limited, and then we can go to a more detailed model as the instrumentation grows in the facility.
Okay, thank you. And how long would a project like that typically take to implement?
Okay, so that's a very tricky question, because we have projects, sprint projects that can be 8 weeks, and we have projects that can be 1 year. Okay, sprint projects they're the low-hanging fruits. Okay, a 3 months project is let's say performance monitoring of an asset. It's a small model, very, very defined objectives. When we go to the larger projects, it's most likely like multiple sites. We are doing very large models, multiple analysis. But if we start with one analysis, a small site, we can go towards the 4 months. Okay, and maybe very simple integration. Everything is already in, let's say, the Aviva Pi, which we connect natively to. Let's say they're also accepting our standard reports. When we go to the longer projects, it's like we're integrating to multiple data sources, to the SAP, to a schedule and planning system, maybe from Aviva. And we are doing, we have customers that we've done tens of reports, a lot of custom reports in different technologies and so forth. Those are the things that, let's say, grows the implementation. But we can start small and we can go big in time.
Great, thank you.
Thanks, Caroline.
Okay, and we are out of time.
Yes, I realize.
Thank you very much. And again, it's about the value. We don't build bridges for fun, but to get somewhere intentionally for a particular reason. And I would like to invite everyone to please get in touch if you have any further questions, if there's any assistance that you require on your own journey to business transformations through digitalization. And I hope you derived value out of the session, which is another reason why we're here. Thank you very much. See you soon.
Thank you. Goodbye.
Bye-bye.